Okay, so right now I'm going to show you how to do the partial quotient method. This is something that we've been doing in class for the last 2 days. Today we're going to be having a short assessment on it, but whenever I send home homework, you'll have examples to do in case your child needs any help. So let's start off with a very simple problem, one that probably everyone can just get off the top of their head. Let's just do 50 divided by 5. Now, we learned inside class that division is just an inverse operation of multiplication. So we know that something times 5 would equal 50. We already know that the answer is going to be 10. But I want to show you how to do it inside the partial product method, because this is how your child is going to be tested on the FSA. So the way that we have to set it up is just like a standard algorithm for division. We know it as long division. So we put the 5 on the outside, which is our divisor, and we put the dividend inside. Now we need to pretend that we don't know that 10 is our quotient. So we are going to start taking chunks away from the 50. So can they raise their hand and tell me what our rule is? Nice and loud. Colin?
5 tens and hundreds are our friends.
5 tens and hundreds are our friends. That will make sense shortly. So I'm going to model that. I don't know. I think that 10 might be too much. So I'm going to multiply my divisor 5 by 5, because I know that 5 times 5 is 25. What we have to do here is subtract. We have to regroup. 10 minus 5 is 5. 4 minus 2 is 2. I still have 25 left over. What should I multiply my divisor by to get rid of this 25? Eli?
5.
Another 5. So I'm going to do times 5 again. That's minus 25. And I end up with 0. Can someone raise their hand and tell me, what do I do with these two numbers right here? Preston, nice and loud.
You add them.
Add them. Well, we can do this inside of our head for mental math. 5 plus 5 is 10. So our quotient, everyone, is
10.
10. So that was a very simple problem. Let's get a little bit more complex. Let's do 184 divided by 2. Not something that we would really necessarily know off the top of our head. Once again, can someone raise their hand and tell me our rule? Cage, nice and loud.
5 tens and hundreds are your friends.
5 tens and hundreds are our friends. So if I multiply 2, which is our divisor, by 5, that's going to be 10. Should I go with that?
No.
Colt?
No.
Why not?
Because
Look at me. It's way too what? It's way too what? It's way too small.
Yeah.
We would be here doing this forever. So let's move up a little bit. Should I multiply 2 by 10?
No.
Eli, why not?
Because that would equal 20, and it would be a small amount.
It would be way too small of an amount. We would be here forever.
Yeah.
Should I multiply 2 by 100? Emily?
Yes.
Really?
No.
Why not?
Because there's only 100, and it's like you can't do 200.
There's only 184. If I do 2 times 100, that's 200, and I cannot take 200 from 184. So the rule is 5 tens and hundreds are our friend. Are there other tens besides just the number 10?
Yeah.
Yes, I'm seeing yeses. Ken, what's another 10 that we could do?
80.
80? Okay, let me think. Well, I know that 2 times 8 is 16. 0, the hero flies in, that's 160. Would that take a good chunk out of 184?
Yeah.
It absolutely would, so let's do that. Times 80. 2 times 80 is 160. We have to subtract that. I'll do this part. 4 minus 0 is 4. 8 minus 2 is 6. 1 minus 1 is nothing. Now it's a much smaller number, correct?
Yeah.
Do we know something times 2 that equals 24? Tim?
12.
12. That's from our times tables that we should know and master from 3rd grade. So I'm going to do times 12. 2 times 12 is 24. Got 0 left over. What do I do with these two numbers, Juliana?
Add them.
Add them. I'm going to write it over here in the standard algorithm. 80 plus 12. 0 plus 2 is 2. 8 plus 1 is 9. What is this called, ladies and gentlemen? Everyone.
Quotient.
That is our quotient. And I didn't leave myself very much room. 92 is our quotient. So far, everything has been equaling 0, which is nice. But what if we didn't end with 0? What would that be called? Preston?
A remainder.
A remainder. So let's do a problem where we are for sure going to get a remainder. This time let's do 267 divided by 5. We already know that this is going to have a remainder. How do we know? Like how can I already tell that this problem will definitely have a remainder? Cage?
It's not even.
It's not even, neither is 5.
Yeah.
All factors of 5 end with what two numbers?
5 or 0.
5 or 0. This does not end with a 0. So, the rule is 5, 10s, and 100s are my friends. Should I multiply 5 by 5, Aiden?
No.
Why not?
Because 5 times 5 equals 25, and that's way too small, so it would take us so long.
It would, yep, it's way too small, would take us forever. Should I multiply 5 by 100? Tim?
No, because it's too big.
It's too big. 5 times 100 is 500. We can't take that from 267. So what is a 10 that I should multiply by to take a nice big chunk out of 267? Dakota? 60. What's 5 times 6?
30.
Put a 0 behind it.
360.
306. Where'd you get 360 from? 30 with a 0 behind it. 300. Is that too big?
Yes.
Go a 10 smaller. Would that work?
Yeah.
What would it be? It's 5 times 50 now. What would that be?
250.
250. Is that small enough?
Yep.
Yeah. So we're going to do 5 times 50, which equals 250. Thank you, Dakota. 7 minus 0 is 7. 6 minus 5 is 1. 2 minus 2 is nothing. Now we're down to 17. What can I multiply 5, our divisor, by to take a nice big chunk out of 17? Preston?
You can multiply it by 3.
By 3. What would I get?
You would get 15.
15. Will, what is this called?
It's called the quotient. Wait, no, that's called the divide. Or no, that's called the remainder.
Woo, boy, we found it. It's called our remainder. Is this a good remainder? Am I allowed to have this as a remainder?
Yes.
Yes.
How do you know, Tatiana?
Because 5 it's because 2 is smaller than 5.
2 is small. The remainder is smaller than the divisor, so you're allowed to do that. Who haven't I heard from? Taylor, what do I do with these two numbers?
Add them.
Add them. 50 plus 3, everyone?
53.
And I'm done. Right?
No.
10?
You gotta add a remainder.
Gotta add my remainder.
It has to be capital.
And it has to be capital. Remainder 2. All right. Parents, I know that this is not the method that we grew up learning, but this is the method that our children will be assessed on. So we need to make sure that we master this. Thank you for watching and stay tuned for more. Cut.